We have Shouvik Banerjee. He's actually speaking to us from Washington, D.C. Unfortunately, he couldn't make it in person. We had some scheduling conflicts, but we have him online. We also have a lot of participants online as well. So we wanted to make it a hybrid approach and have a more inclusive audience. Shouvik, you want to introduce yourself and get started?
Sure. Now, I also come from an engineering background and have been working with data and analytics for some time now, 2 decades. And of late, as we all are aware, right? Every single day the landscape of LLMs and generative AIs are changing. But the main thing is this energy around this, we have to channelize it properly, and that's what we have done. What we call as bot assisted MQ framework. So this we have seen and we strongly believe for budding entrepreneurs like you, this will be the tool of choice to take the ideas from your head to the hands of your potential customers. That's the goal of this whole discussion. And here we have tried to put all our brains together to create something to make your lives easier, to be honest. Before we talk about what it is and all that stuff, idea is from concept to market. That's fine. But what are the steps in between, right? So when you try to create a product, you have to first think about what the customers might want, what are the typical personas that kind of creates a requirement for you. And then you start designing the product. Then you step by step get into creation of codes or creation of some construction of the product. And it has to go through some quality checks or quality assurance or testing. So these are typical steps, be it software, be it a hardware, firmware product, whatever it is. A typical flow is always like this. Now, what BAmF tries to do, it tries to shorten that path from your concept to the product. Whatever intermediate steps are there, it uses the power of generative AI to shorten that path. And how it does it, now let's talk about that. Now, when you have an idea, let's say a product, a research tool, a startup concept, whatever that is, the gap between the idea and the prototype is real. Not because the idea is hard. But the turning that idea into a product, that can be done in different ways. But if you do not put a structure between these two things, it may take too long before the time market might evolve out, right? So that's why what we see on this slide is the ideas from the conception of a software to how to get the software in the hands of a customer. And every item on this slide is a step in that journey, right? So requirements tell the AI what to build, and then the design tells how to build, and the tests define what success looks like. So these steps, as we call, sometimes think these are just documents. These are not. These are basically the part of a structured workflow that makes the whole product creation process through AI very reliable.
Shouvik, just one point
Yeah.
here. How many of you are familiar with something called SDLC, Software Development Lifecycle? Any one of you are familiar with this? So generally what happens is when you prepare let's say mobile application, right? You want to launch an app where you want to sell a particular product, maybe a service, right? Or maybe just have a, like a discussion forum like Discuss, whatever. So end of the day, it's a software product, right? So that you are trying to develop. Or maybe it's a website, you want to do some retailing, right? So that's also a software product. So any software product by pure definition of software engineering goes through a life cycle, which is called software development life cycle. Broadly 4 phases. The first one is to determine the requirements, the what and the why, right? So what are you going to do and why are you doing it? So that defines your target customers, right? That this is for student community, right? Or this is for retail as a large for let's say young generation or whatever, services for elderly people, for healthcare, whatever, right? So that's your what, and then also the why. So that's the first stage, which actually is a requirement gathering stage. And then after requirement, we go into basically design the details, right? And then the construction starts. So in the design, what we do is we define the how. How is all about how that software or the mobile application or the website will get developed, right? So for example, what technology stack will you use? What are the data elements that you're going to capture, either from an external source or from an internal source or from the user inputs, right? So they all come under design, and then the development starts. So once you have done that, then you do the development, and then finally you do some testing, right? Quality check that whether the application or the software or the website that you develop is working as per the initial design that you had, or is catering to the requirement that you have done, right? So so if you look at it, that 4 phases: requirement, design, development, and testing, has multiple components into it. So in terms of that SDLC, what Shobik is saying is, for example, when you talk about SRS, this is a lingo which stands for SRS, stands for software requirement specification. So that's where you define the what, the why, and also the how, right? As much as detail. The how is elaborated more in the HLD, LLD, which are the high level and low level design. For example, which particular technical stack will you use? For example, what database will you use to store the data, right? What would be the data model like, so on and so forth, right? And then see, when you design your software, you typically also think in mind, who are the personas who are going to use it? For example, let's say if you're talking about a retail website or a retail mobile app, arguments like Amazon itself, there are different personas who are going to use that. So for each persona, you have to think how that persona is going to use it. Every persona has a different need. Every persona has a different, I would say, attention span or the kind of product that that persona is going to buy. So we call this as user stories, right? So that's, for example, a day in the life cycle of an end user. How will the user use the app or the application to finally do the outcome? What is the outcome? Buy a product, right? Or start a chat, or write an email. Gmail is typically a software app itself, right? So those are the user stories, right? So these are the individual blocks which are there in an SDLC. Now, when let's say we started off our career, me or Shobik way back, so all these steps went through a lot of heavy lifting. So you have to write pieces of code. If you have heard about software languages like Java, C++, we used to use those languages to write like heavy lifting, write codes, compile them, bundle them together. So it was a pretty long effort, right? Today, because of the presence of advancement in the technology space, so this heavy lifting has really gone down. And what Shovik is saying is that heavy lifting can be done very easily with the framework that he's going to explain. Okay, so this is the context. So these are all building blocks within the SDLC, and he is showing you the framework which is going to phrase it. Do you get my point, what I'm trying to say? Yeah, makes sense? Cool. Thank you, Shovik.
Perfect. Thank you. So now this heavy lifting that Amitabh talked about, I mean, because it is that, I mean, it takes a lot of time to build softwares, right? Now, one example just to start with. So when we used BAmF, before using BAmF, a project was estimated to take 1074 person hours. So if one person does it, it will take this many hours. If a team of 4 person does it, it will squeeze down, but it will still be a significant time. It is about 6 person months. With BAmF, with this software bot assisted framework, we could bring it down into 273 person hours. This is a real number. And why I'm saying this is because when you build your product, you already know this power exists. You can build your product in this level of speed. Now, how is that possible? That is possible because, see, I mean, one important thing is in today's day and age, there are tools floating around everywhere, right? This is one of the tools. There are many other choices here and there. The problem with lot of AI tools we have experienced over time is they miss the core thing, which is the context. So, for example, if you want to build a product for elderly people, you need to think of the persona. What is the day in life of that elderly people's life, right? And then that forms the requirement. If you do not have that context given properly, if you directly get into an AI tool and start giving prompts to it, it might generate something, but it may not really match with what you intend it to do. There is hallucination into it. So how to solve that? This is what is solved in the framework here. So what we have done, what we do here is this entire set of steps, right? So from the requirement to design, what Amitabh just explained, all of these steps, they keep on working like a chain reaction. So they take the context from requirement, which is what are the what are the whys and what of the product, to the design phase, how do we do it, what are the components, what technologies, etc., to the development phase when we are writing the software code actually, right? And important thing is this is an accumulative thing, right? So whatever context we have given in the requirement, when we reach the development phase, we do not lose the context of requirement because it by definition is part of the design itself. And that is why we have been able to really develop a software in such a short time with the right quality. That's the main thing in this. How does it work? Now it has got two main things into it. If we think about it simply, we call it a maker input checker framework. The input is the context. So and we will in few minutes we'll show what we mean by those inputs. Now when we give the context, like what is the personas they look like, what are the features in the product I want to do, those are the requirements context given to it. Then the generative AI or the agentic bot, let's say, generates or makes the deliverable. But that's not the end of it, right? I mean, as we understand that it requires what we call human in the loop. HITL is human in the loop, which is basically nothing but we humans as expert into what we want to do, we do revision of what generative AI has given to us. And with technology, there are ways to make generative AI review its own output that you might have heard already, right? Which we call reflection. So it generates, let's say, a design document or a code. We can ask it to review it with respect to the given context. So one round of review happens. A better matured output comes to us as humans. We do the final review of the whatever remains after that, and that feeds back into the process, and that's how the chain reaction happens. What is the benefit of this? The benefit is that you are not leaving it to the hands of generative AI to hallucinate. You are letting it generate, but you are in control. You are the checker in the process. And through this, it basically keeps on going through the chain reaction. So, so after requirement, you do your review as a human, and then it gets fed back. With that, it revises its requirements. Then it gets as a context into design, so on and so forth. I will show you some examples of very quickly. But before that, one important thing that there are different ways to approach the same problem. For example, there are a lot of new classes of tools that really can generate an application from a single prompt, which is genuinely impressive as a demo, but it is genuinely incomplete also. Because why is that? That's because, see, these tools, they start at the code. They don't really touch the requirements. They don't produce a design document, right? So that is why what we call as a traceability that doesn't exist. Traceability means that if you see some code, you need to know which design this came from. If you see a design, you need to know which requirement it caters to, right? That is the traceability. So that traceability is missing if we use an AI tool directly to create a code. That is the problem. This works for a hackathon, but for a real product which will be used for maybe a specific industry or specific customer's real needs, it will not work. That's the reason why we need this context and the chaining here. And same process goes on, but in this, as we see, that the speed comes from the machine for each step, and the human checker makes the quality assured, right? Now, what we have done so far, I'll quickly touch, and then we'll go to the demo fast. That we have done, one example is this. In one of the projects, we started the project, we estimated that requirement phase itself to take 130 person hours, which is maybe close to a month. That we could bring down to 41 person hours. That was a 75% effort saving there. On the same project, when we moved on to development and unit testing, a bigger impact happened. So there we could actually generate codes which we estimated to take 576 person hours. It took 43 person hours, 93% saving. So that's how we have proven the usability of such a framework into actually creating a product, software product. And the same concept applies to even hardware firmware products also. How it looks like, so what happens in this process is the generative AI creates the required code for the software components to work. For example, in the application, we have screens, we have filters, we have different type of widgets, as we call it. All those codes are generated in the generative AI, simply gets imported into the platform we are using called mcube, and immediately the front end comes from there. Another quick example where the type of project was different, just to tell you the fact that this framework that we are talking about, it is not specific to one single type of project or one single type of product. It is pretty general purpose. So this is a different type of example where the goal was, it's a common requirement in the industry where we want to modernize applications. We have a existing toolkit. We want to migrate the whole thing to a more modern toolkit, right? In this migration, it takes a huge time. So that's how this project was estimated to take 3.8K hours, person hours. But with BAmF, it was brought down to 728 hours. But how could we do that? Here, earlier we were simply talking about requirement design code, right? Here the approach was different. Here what we had to do was, we had an existing product, a software was there. We had to migrate that, which means first we had to reverse engineer that and create, from that software we created specifications. A human then could easily review what is the structure of the product. It's like translating from one language to the other, right? So either you can translate word by word or you can translate through the intent. It is like that. Here we are translating from one tech to another tech. So through reverse engineering and then forward engineering, we created the code, and that brought down the time. Now, with the actual demo, now let's walk through the full framework or the BAmF chain for one of the example research products. So we have gone through few of the things which are, I think, right now work in progress among all of you. Uh, One of them is hydration variables, smart in source, etc. We have taken one example to give an idea of how this works. Okay. Now, if we think of it first conceptually and then how it works in the actual framework, conceptually, these are what we mean by requirement design, etc., etc. So when you start creating a hydration variable product, the goal of this is what? The goal of this is to check the hydration level in a human body over time, right? And if the hydration level goes down, health risk. So that's the product. Now, for that, the starting point will be, because whoever is researching this product to bring the concept to the market, they know that it has to work with some kind of a bioimpedance sensing in it, right? And then, so for that process, the bioimpedance sensor will give you signals that should go through specific set of data processing to actually show some alerts to the user, right? So the requirement step, you say all of that, that what a user typically will be doing. He'll be wearing a wearable, the signal will have to go to his mobile, those kind of things, right? In the design, you say that how do we implement that? Now for this, because there is a question of bioimpedance, you are talking about something like a AD5933, that's the sensor. Right? So that's the design piece. Now you are materializing your requirements to design. From there, you are creating some software. How this signal will be converted to an alert. So there will be some specific data processing or some functions, which is the code part of it. So hydration task, impedance to hydration conversion, so on and so forth. But that's not enough, right? So because you have to ensure the product is really usable, there's the quality assurance, which is the testing piece, where we are then testing through different test cases. And all of these, what are the test cases? How to automatically test? All of that is generated using the framework. And finally, when it is ready for shipping, you do some market study, you do some initial early adopters testing, basically, right? So there, on that, you start getting their feedback, incorporating. This whole cycle is managed by this single framework called BAmF. Now let's see how this. We tried to basically create this in a very short time, obviously. So what we did was, what we created is, I'll just share the software screen now very quickly. This is what we intend to create at the end. I mean, this is the final product. Let's say, right? We intend to create it, and now I'll quickly show you how using BAmF we could do it very fast with the help of machine speed, right? Now, what we want to do here, we want to basically show different types of alerts and metrics about the hydration level of somebody who is wearing that device, right? It shows different trends, like how the hydration goes down over time, maybe what's the current state of it, and then the different associated factors such as sweat rate, sodium, potassium levels, skin temperature, etc. It also shows a hourly fluid projection. So where it shows that over time, what is the fluid deficiency rate, etc. So all of these different metrics, that is the outcome. But how is that created? Now let me show you the BAmF itself, how it looks like, right? So the BAmF looks like a simple conversational screen, but with a lot of context. So if I go to that, it is this. So here, as you see, we started with the requirements. The first interaction with BAmF was this. We gave it a prompt. We said that we want to create, we have some input context, which is basically, I'll show you where it is. So here, before we start the conversation, we have given a set of, I'll just quickly open that piece. We have created a project, as we call it, which is the iteration variables project. Within that, we have added some existing context files, which are simply Word files or PDF files or whatever format they are. They're not really anything fancy. As part of this, we had given our initial idea of the product so that we can create a more detailed set of requirements, right? So these are the things that we have given. And now when we talk to BAM, we refer to those. We say that the input is the requirements dot markdown file, and then SRS, there is a specific, SRS the software requirement specification. But we want that software requirement specification to have certain sections. It should talk about, for example, user stories, which user will use it how. Or it should talk about non-functional requirement, which is what should be the response speed. So that template talks about what are the sections that are required. And then we have which technology we'll use to implement the software. In our case, we're using mcube. So we said how mcube behaves, that we have documented somewhere and passed into it. It is baked into BAmF as an existing context. So now what happened is when we speak with BAmF, because we have given those context already, it knows how mcube behaves. It knows what a software requirement specification document looks like in terms of structure, and it also has basic idea of the product given to it as requirements.md markdown file. And then we say analyze this standard prompt, and our output should be this: a software requirement specification for we are calling it SRS underscore agentic plane, because agentic plane is the interface through which we talk to BAmF. So here, what we do here is, as you see, here we can do simple conversations. So like you can do anywhere, you can do ChatGPT everywhere, right? But here, the difference is these contexts are preset and you can easily switch between different providers. So let's say you are using ChatGPT for some other purpose, you need Gemini. For something else, you might need Claude. Right? So we have all of these options and we quickly flip between these. And that is how this product helps us create the deliverables just using that prompt and the context. So what did it create out of it? So what it created was this document. This is the output of this document. This SRS agentic plane looks like this. So here it has created the complete specification of our requirement, what we want to do, including what metrics, what personas, etc., etc. And once we have done that, we went back to again BAmF and we said, now let us create the design. So what we did next, we went to this conversation where we have used, if you see, we have used first that requirement document as the input. So what we generated earlier, the requirement document now becomes my input to the next step. That's how the chain works, right? So here the agentic plane SRS has been given. We again have given a template for the high level design document. So what is the typical set of sections in a high level design document? We have given that. Means all of the same process happens. It generates a high level design document and it looks like this. So if I open that HLD document, it looks like this. So here it creates the standard sections such as what are the different tiers or layers of the application, data layer, application layer, backend layer, so on and so forth. So that's how it works. That's how typical software works, right? And through that, we step by step go into further and further detail. We go into something called low level design, where we actually talk about exactly how the screen should look like. So if I talk about the screen again, here, each of these, as you see, is not only just the interface, right? It has to work with my data, which is coming from the device itself, right? There is a certain flow you have to talk about. You have to say that, okay, I want to show, for example, this bar chart. This is a bar chart, as we call it, and this will have what are the different things we want to show, and to show the level of fluid based on by hour and based on some other index such as a heat index. So you are given that as a requirement. So if we take one example, you will clearly understand how could we generate through a chain. So for example, if I talk about this bar chart here, how did it get generated? This one actually came from a JSON file that was simply imported into the software, and that created this chart. So what is the JSON file looking like? It is this. So this is a JSON file if you are familiar with JSON software part of it. Otherwise, don't worry about it. This is simply a specification about the screen component. It says that what are the different, for example, in the screen, we see that it is something called hourly fluid projection. It has got a bar chart, right? So that is what it will talk about in this JSON file. And it will then speak about how it will fetch the data for it, right? So it will mention, for example, something called APIs or application programming interfaces, which basically talks to databases and brings the data to the application, right? So it talks about where it is going to bring it from. But how is the JSON file generated? The JSON file is generated from the low level design. So now you understand the chain, right? So we have the ultimate application, which you want to deliver to the customer or to the market, which is the dashboard. This is what I want to deliver to the market. But to create it, now I have created the full things for chain reaction. So these got created from the JSON. The JSON got created from the low level design. That got created from the high level design. That came from the requirement. And this gives you the confidence, not only speed, it gives you the confidence. This whole thing happens in 2 days probably. That's one thing, that's the speed. But in those 2 days, you don't create a junk. It is a completely production ready thing to go to the market. That confidence comes from this chain reaction, from the requirements to the final product.
Yeah, thank you all for coming. Yeah, thank you for coming. And if we're here, if you have questions you want to ask us directly, just come in the front. So thank you.
Thank you, Shodek.
Thank you for those online.
Thank you, everyone. Thank you for joining. Bye.